We all grow up thinking math is, well, math. It's the one place where answers are either right or wrong, solid, dependable. But what if that whole idea is just a myth? Today, we're going to dig into a story that completely shatters our perception of what numbers really are. So let's just start with this big, provocative question. What if math isn't the absolute, unchanging truth we've all been taught it is? What if its very foundations are more human, more creative, and frankly, a lot more colorful than we ever dared to imagine? For the longest time, mathematics was viewed as this impenetrable fortress, right? It was this perfect world of pure logic, where truths were discovered, not invented. And every single statement was either definitively true or definitively false. No gray areas. And look, this wasn't just a classroom thing. This was a deep philosophical belief. Math was the bedrock of certainty in an otherwise chaotic world. It was seen as the one pure language that could describe the universe perfectly, totally separate from messy human opinions and errors. But then, right around the turn of the 20th century, something started to go wrong. As mathematicians dug deeper and deeper into the very foundations of their field, they started to find cracks in that perfect fortress. And all of a sudden, the unshakable started to shake. This whole period became known as the crisis of mathematical foundations. Think about it. Paradoxes started popping up in set theory, the very language used to build all of modern mathematics. It was like an architect finding out the blueprints for a skyscraper were just fundamentally wrong. Everything, and I mean everything, had to be reevaluated. This crisis kicked off a complete revolution. It forced mathematicians to move beyond that simple binary world. Logic itself had to transform from something black and white into something colored. It was suddenly full of nuance, context, and believe it or not, human choice. So the first major casualty of this whole crisis was the idea of absolute truth. Mathematicians began to realize that the truth of a statement wasn't some universal floating thing. Nope. It depended entirely on the system you decided to work within. So how did this actually happen? Well, it really broke down in three key ways. First, the rules of logic you decide to start with, your axioms, they completely shape the truths you can build later on. Second, even super fundamental ideas, like what it means for two things to be identical, turned out to be flexible, not fixed. And finally, a proof is only valid within the context of the theory it's a part of. This was just a massive, fundamental shift in thinking. We went from seeing truth as this single, absolute, unchanging thing, but we realized it's way more like a painter's palette. The truths you can create depend entirely on the foundational colors, the axioms, that you choose to start with. But okay, truth becoming relative, that was only part of the story. The crisis cracked open the door to an even more radical idea, that the human mind isn't just a passive observer of mathematical truth, but an active, essential creator of it. This quote, wow, it really gets to the heart of this new philosophy that was bubbling up. The idea here is that there isn't some external, perfect world of numbers just floating out there waiting to be discovered. Instead, mathematical reality exists entirely within the constructs of our own thought. And this school of thought has a name. It's called Intuitionism. Intuitionists argue that math is a mental activity. It's something we build step by step using our own rational intuition. So, logic doesn't come first. Our intuitive grasp of concepts like numbers comes first, and logic is just the tool we use to talk about it. And if you follow this line of thinking, it can lead to some truly mind-bending places. I mean, take one of the most basic laws of logic. Something can't be both true and not true at the same time, right? Well, a philosophy called ultra-intuitionism pushes this whole thing to its absolute limit and asks, are we really so sure about that? To really get their point, you have to understand something they call the act of identification. So when you look at the formula A and not A, you just automatically assume the first A is the exact same thing as the second A. But ultra-intuitionists say, hold on, that identification isn't automatic. It's a mental act. It's a choice we make. So here's the kicker. A contradiction only exists if we actually perform that mental act of identification. If we choose not to, well, there's no paradox. From this perspective, even the law of non-contradiction, the absolute bedrock of logical consistency, isn't an absolute truth. It's a convention. It's an agreement we all make to keep our systems tidy. So where does this whole journey leave us? Well, it's taken us from a world that was rigid and predictable to one that's way more dynamic, human, and honestly, a lot more interesting. It has totally changed what we mean when we even talk about truth in mathematics. So let's just pause and nail down the big ideas we've covered. First, mathematical truth isn't absolute. It's relative to the starting points you pick. Second, the human mind isn't just a calculator. It's a creative force in math. And third, some of the most basic rules of logic we take for granted, you could see them as useful agreements rather than ironclad laws of the universe. And this really is the perfect way to wrap it up. We started inside that black and white fortress of absolute certainty. But the foundational crisis completely shattered that myth, and in its place, it unleashed this vibrant, colored world, a world where math is a story of context, choice, and human creation. And that leaves us with one final, pretty profound question to just chew on. If the one field we all thought was perfectly objective turns out to be a deeply human story, shaped by our choices and our intuition, what does that tell us about our search for truth in every other part of our lives?